So this video is meant to review how to determine whether or not your table of values shows a proportional or an additive relationship. And we've got proportional relationships here on page 1, and we're going to explore additive relationships on page 2 in a second. But let's get started here with proportional relationships, and a friendly reminder that when your two quantities, the x and y, vary in such a way that one of them is a consistent multiple of the other, that's when you're dealing with proportional. Your equations are going to have a coefficient, and that coefficient m is going to be called the slope, also known as the rate of change when you're dealing with a real life scenario. So for the first one, what we've got here is that you've got 1 times 2, 2 times 2 would be 4, 3 times 2, 4 times 2 would be 8. So this equation is y equals 2x, and 2 here would be the slope. In the next table, you can see that you've got 2 times 5, 3 times 5, 4 times 5, 5 times 5. So our equation is y equals 5x, and 5 is the slope. In the next one, if you just multiply by 3 every single time, you've got your coefficient's going to be 3, so y equals 3x. And in the last one, this table of values just shows the x column. Instead of it being first, it's up above. And you can see here, you've just got to move from the top to the bottom here, and you can see the times 4 relationship. So y equals 4x. So anytime your proportional equation shows multiplication, you're going to have a coefficient in your equation. With this one, for example, you can see that if we do 1 times 6, it would be 6, and then 2 times 6, you're expecting a 12. So that's how you know this is not proportional. For this one, if you do 1 times 8, that would be times 8. But then if you do negative 1 times 8, you'd expect a negative 8 here. So you can see you're not multiplying by the consistent multiple of each other. And for this one, you'd have to do times 2. And then here's a times 3, and then a times 3. So because they're not all times 3, this one is a non-example. Now, I did want to call your attention here in blue that your proportional relationships can deal with division in the sense that if you're multiplying by a half, that's the same as dividing by 2. So if you take half of 10, you're at 5, half of 8, you're at 4, half and half. So this right here, where you have a coefficient of 1/2, yes, this is considered proportional, okay? So what you're going to do here is you're going to pause the video and you're just going to determine if 1, 2, 3, and 4 is proportional or not. If it is proportional, you're going to write the y equals equation, and if it's not proportional, you don't have to write one of those equations. And your answers to this part's going to go in the form. And so pause it here, but I'm going to keep going in the video now to page 2 to talk about additive relationships. So for the additive relationships now, what you're looking at is just a constant where you've taken each of these input values and you're adding to get the outputs, and your constant here would be the number that you're adding. So for example, 0, 2, you add 2. 1 plus 2 is 3, 2 plus 2, you're adding 2 every single time. And here you can see that you have a constant of 2. In this situation, if you add 3 and then add 3, add 3, add 3, add 3, so our constant here is going to be 3, and our equation would be y equals x plus 3. Now would be a good time to call your attention to 0, 3 and 0, 2 for additive relationships. That lets you know where it's going to start on the y-axis. So for example, if I were to graph the very first equation, y equals x plus 2, I can graph this equation right here without needing this input-output table. I could simply start here at the plus 2, and then because my coefficient is this 1, I can simply move up 1 over 1, up 1 over 1 and plot a point. I'm going up and over, and that right there would be the equation for y equals x plus 2. And of course we have an arrow here, and it would continue on this way. So this would be the equation for y equals x plus 2. The only thing that would change now if I have y equals x plus 3 is that instead of starting at 0, 1, 2, it's going to start at 0, 1, 2, 3. But you'll notice, because this is still a coefficient of 1, I'm going up and over, up and over, up and over. So it's essentially the same line. You'll see that it's parallel there. It's essentially the same line. Sorry about that. And the only difference is that instead of crossing at plus 2, it now crosses at plus 3. Also, now is a good time to go back and remind you that for the proportional graphs, you're going to see 0, 0. Here's 0, 0. Here's 0, 0. These pass through the origin because anytime you multiply that input of 0 times any number, so 0 times 4 is 0. 0 times 3 is 0. And even in this table of values, you can see the pattern continuing 25, 20, 15, 10. So there'd be a 5 and then a 0 up here. So 5, 4, 3, 2, 1, 0. Once again, there would be the origin that this passes through. And for this one, if the pattern were to continue, there is your 0, 0. And again, it passes through the origin. So in your Google form, you've got your answers to this part. And now you're going to come over here and you're going to have your answers to this part. But before, let's take a look at these real life scenarios and let's just review real quick what type of relationship it would be. If a test has 20 questions and each question is worth 5 points, we want to know if that would show a proportional or an additive relationship. So you're going to get 5 points for each correct thing that you get, and that's going to be your total score on the test. So let's say you get 15 questions right, which means you got a 15 out of a 20. That means you're going to be getting 15 times 5 points for each one of them, and that's going to be your total score of 75. Now, of course, in your calculator, you could do 15 divided by 20 and see that that's a 0.75, and it's the same thing. So we've got multiplication here. You're multiplying each question, each correct answer that you've got times 5 points to get your total. So this one is going to be a proportional relationship because we're thinking multiplicatively. Now, if you have a regular size bag and a jumbo pack costs $1.50 more than that, you've got your regular size and you're adding $1.50 to get the price of the jumbo pack. So because we're adding a constant here, that's going to be an additive relationship. So if you're multiplying, you're dealing with proportional thinking, and obviously if you're adding, you're dealing with an additive relationship. So at this point now you've got 6 of them and you've got to decide if it's proportional or additive. And then if it's proportional, you're going to have a coefficient, so y equals something like 2x or 3x. And if it's additive, you're going to have a constant, so something like y equals x plus 2 or y equals x plus 3. Friendly reminder that for proportional, you can see things like a 1/2 or you can see things like a 1/3. And for additive, you can subtract technically. So y equals x minus 3 is technically additive because it's the same as seeing x adding a -3, but you never see adding a -3 anymore. You just see right here. So this up here would be considered additive. And if you see something like y equals 1/3 x, that's considered proportional because you're multiplying by this 1/3. Okay, so I just wanted to review that with you. And there will be a place in your Google form to answer pages 1 and 2. And that concludes this video. Thank you.